The next question is, consider the signal f of t equal to 1 plus 2 cos pi t plus 3 sin 2 pi by 3t plus 4 cos pi by 2t plus pi by 4, where t is given in seconds. The question is, its fundamental time period in seconds is. It's a numerical answer type question. The first thing to remember before answering this question is the presence of DC or constant, right? Constant. Then the presence of a phase shift. These two factors will never affect the periodicity. Never affect a periodicity of a signal. Okay, so the presence of a DC or constant coefficient and a phase shift, both of these will never affect the periodicity of a signal. Okay, now this question is very simple. You can see often simple questions like this in GATE, especially from signals. This is a lottery for GATE 2019 students. Anyway, so to answer this question, there are several methods, but the fastest and simplest method I will tell you. The fundamental frequency omega 0 of this signal is given by the HCF of the argument, right? HCF of the arguments in the numerator divided by LCM of arguments in the denominator. Arguments means it is the bracket inside cos or sine term. So the numerator argument HCF divided by denominator argument LCM will give you directly the fundamental frequency omega 0. So let us see what omega 0 is for f of t. So for the given signal f of t, omega 0 equal to HCF of, what are the numerators inside the argument? You can avoid t, the coefficient of t, without taking care of any phase shifts. So yeah, so here it is in the first term it is pi. We don't need to take care of this thing, okay, and this thing, right? So for the first is pi. So pi. For the second term, the numerator is 2 pi. Okay, 3 is in the denominator. We will take it in the LCM side. Okay, so for the second term you can have it as 2 pi, and for the third term, that is again pi. For the third term it is pi divided by LCM of, now the arguments in the denominator. Denominator means in the denominator of the first term, I mean this term, what is the denominator of the argument? It is 1, right? Actually this is actually equal to pi by 1 into t, right? So the denominator is 1, so I can write it as 1 here. And for the second term, the denominator is 3 for the argument, so I can write it as 3. And for the third term, the denominator is 2, so I can write it as 2 here. Now it's only a matter of finding out the HCF and the LCM. So what is the HCF of pi, 2 pi and pi? The highest common factor is pi here. By what is the LCM of 1, 3 and 2? This is definitely 3 into 2 equal to 6. So pi by 6 turns out to be the fundamental frequency of the signal f of t. The question is to find out the fundamental time period. Therefore, fundamental time period in seconds is equal to 2 pi by omega 0, which can be written as 2 pi by 6, or pi cancels, and finally t equal to 12 seconds. Okay, so the answer for this question is 12.